Let's jump straight into it. We are breaking down WAEC Physics 2026 Question 9 today. We're pulling this directly from the Q&A exam prep library over at QandA Help. Today's explainer is all about decoding the science behind sonar. So, let's dive right in.
So here's the question we're looking at. Sonar is a device used by submarines to detect underwater objects and water depth. The primary characteristic utilized by this device is A. Electromagnetic induction, B. Reflection of waves, C. Temperature, or D. Magnetism. Now look, we're not just going to skip straight to the answer key here. We're going to break down exactly why the right answer is right. That way, no matter how they twist this question on exam day, you're going to be fully ready for it.
You know, our first massive clue is actually hiding right there in plain sight. SONAR is an acronym. It stands for Sound Navigation and Ranging. And honestly, that very first word, sound, is a total game changer. It immediately tells us exactly what kind of waves we're dealing with. Just by knowing that one word, we can already start crossing out some of those multiple choice options.
Before we go any further, I want to give you a really helpful shortcut for these types of physics problems. Keep this golden rule in your back pocket. Whenever an instrument sends out a wave and receives it back, you need to be thinking about reflection. Seriously, whether we're talking about a massive submarine or just a tiny bat flying around in the cave, if a signal is going out and waiting to return, we are absolutely looking at reflection.
To really picture this, imagine a submarine cruising deep underwater. It's acting as a sender, literally pushing sound waves out into the water, traveling downward toward the rocky seabed. We call these transmitted sound waves. The sub is actively pinging its environment. But here's the thing, sending that sound out is only half the battle. If it actually wants to detect anything, something else has to happen.
Think about it. When that transmitted sound wave hits the ocean floor, it doesn't just stop and disappear. It bounces right back up. And in physics, we define that bouncing action as reflection. It's really that simple. When that reflected sound wave finally makes its way back to the receiver, well, in everyday life, we just call that an echo.
Now, if a giant nuclear submarine feels a little bit too abstract, let's bring it back to basics. Just think about standing in front of a really tall brick wall and shouting. The sound of your voice travels through the air to the wall, bounces off, and smacks you right back as an echo. Believe it or not, the submarine is doing the exact same thing, just underwater. It sends out a sound pulse. That pulse hits the seabed, and a reflected pulse returns.
So it all boils down to a super simple four-step journey. First, the sound wave gets sent out. Second, it travels and strikes an object. Third, it reflects off that surface as an echo. And fourth, it makes its way back to the submarine. That continuous loop right there, that is the absolute foundation of how sonar operates.
Now, the original question also mentioned detecting water depth, right? Well, since the sound travels all the way down and then all the way back up, it's making a round trip. So if we figure out the total distance, which is just velocity multiplied by time, we just have to divide that whole thing by 2 to get the one-way depth. Honestly, we don't even need to calculate that to solve this specific question, but I think it's pretty cool to see how the math perfectly backs up the physics here.
Okay, let's pull those options back up. Now that we know how this works, we can spot the traps from a mile away. Option A, electromagnetic induction. That uses magnetic fields, not sound. Strike that one. Option C, temperature. Sure, the temperature of the water might slightly tweak the speed of the sound, but it's absolutely not the primary mechanic being used to find objects. And option D, magnetism, totally unrelated to echoing sound waves, so that's out too.
And that process of elimination style leaves us with option B, reflection of waves. It is literally a perfect match for the echoing principle we just talked about. The sound goes out, it bounces off a surface, and it comes right back. See? Just by breaking down what the SONAR acronym actually stands for, the answer basically reveals itself.
I want to give you guys a great mental shortcut to lock in for exam day. Just remember this simple chain reaction. Sonar means sound. Sound bouncing back creates an echo. And the formal scientific word for an echo is reflection. Seriously, memorize that little chain, and you're going to instantly breeze through any similar questions they throw at you.
Let's do a rapid-fire recap of the whole shebang before we test ourselves. The submarine sends a pulse. That pulse hits a target, it reflects as an echo, and boom, the submarine detects it. It's just this continuous closed loop of information, and it's based entirely on wave reflection.
All right, let's see how well this is sticking. I've got a quick quiz for you to see how this concept applies in other scenarios. Question 1. Which phenomenon allows a person to hear an echo? Is it A, refraction,
B. Reflection, C. Dispersion, or D. Diffraction? Take a quick second to think about what an echo actually is at its core.
If you guessed B, reflection, you nailed it. An echo happens entirely because sound waves bounce off a surface and shoot straight back to your ears, rather than bending around or spreading out.
Okay, round 2. For this quick quiz, let's apply that math formula we touched on earlier. A sonar pulse takes exactly 2 seconds to travel down to the seabed and return. Now, if the speed of sound in water is 1,500 meters per second, what is the actual water depth? Remember our hint, depth equals velocity times time, all divided by 2.
Let's plug those numbers in. The velocity is 1,500 and our time is 2 seconds. Multiplying those together gives us a total trip distance of 3,000 meters. But wait, since that's a round trip down and back, we have to divide that by 2, which means our water depth is exactly 1,500 meters. Honestly, once you know that little divide by 2 trick, the math is incredibly straightforward.
All right, one last check. Let's circle back to the exact definition from our main WAEC problem today. Which device uses reflected sound waves to locate underwater objects? Is it A, a transformer, B, sonar, C, a thermometer, or D, a generator?
Come on, you know this one. It's B, sonar. I think we've officially got this concept completely locked down. Sound navigation and ranging relies 100% on the reflection of waves.
So, bringing it all home, the final undeniable answer to WAEC Physics 2026 Question 9 is option B, reflection. As we wrap up this explainer, I want to leave you with a thought. Right now, as you're sitting there listening to me, sound waves are constantly reflecting off the walls of your room. But what other invisible waves are bouncing around you right at this very moment? I mean, think about it. Light waves, Wi-Fi signals? Physics is literally happening everywhere, all the time. If you found this explainer helpful, definitely check out QandA Help at QandAHelp.com for a ton of expertly organized past questions. Keep asking questions, keep exploring, and I'll catch you in the next explainer.